All right, so we're going to prove that theorem I mentioned in the previous video, namely that zero divisors and units are somehow opposites of each other. They're not opposites, but they're disjoint. That you can't. There's no element of a ring which is both a unit and a zero divisor. So suppose we have a unit. So U is in R cross. That was our notation for unit. Then U cannot be a zero divisor. So the way we're going to go about this is we're going to suppose that U is a unit. So U is in R cross. So that U is a unit, and that U is a zero divisor. So now let's write out what both of these mean. So since U is a unit, there exists some V in R such that UV is VU is 1. Since U is also a zero divisor, there exists some X in R such that either UX is 0 or XU is 0. Now, the proof for either of these cases is going to be the same, so we're just going to assume the former. And again, our rings are not necessarily commutative, so we have to, order is important. So assume UX is 0, then, well, UX is 0, and so if we multiply now by V, we get V times UX is V times 0. Multiplication in rings is associative, so we can reassociate. And you proved in class that the product of any element of a ring times the additive identity is also 0, so that's 0. And V times U, well, V was the multiplicative inverse for U. So U is, oh shoot, this should have been a non-zero X up here, sorry. X is not 0. 1R times X is the left-hand side is 0R. But this is the multiplicative identity, so that's saying X is 0R. So X wasn't 0, but we deduced X was 0, so this contradiction. Oops, contradiction. Thus U cannot be a zero divisor. That's what we are contradicting. Okay, great. So the units and zero divisors are kind of separate from each other.